Hey everybody, I am here to record a new video about something I was recently told by Brad Lemley, the latest and greatest of the carnivore diet advocates on Twitter. Apparently he's a science journalist, a contributing editor of Discover and writer at Washington Post. He likes low-carb diets and lifting heavy, and he believes that Peterson is right. Okay. He says that there are unique benefits of carbohydrate restriction, and we see this pop up every once in a while, and so I want to address this particular paper. It was a paper published at the end of 2018 in the British Medical Journal, and it should load up pretty soon. By the way, the reason I'm wearing these glasses is because otherwise I would have to be in almost red, sort of a red light from the entire household. So instead I decided to turn on some lamp lights right in front of me so that people can actually see me. And so I need to wear these blue blockers because otherwise melatonin production gets suppressed and it doesn't recover for the entire night and sleep quality is compromised. I'm speaking so quietly because my wife and two daughters are in bed and I'm trying to be quiet. Hopefully the new microphone that I have will be able to carry me through. Here is the BMJ randomized controlled trial. The principal investigator was David Ludwig, who is a professor at the Harvard School of Medicine and the director, I believe, of the Childhood Obesity Clinic at Boston Children's. This is a widely touted study that had been planned and talked about for some time. It was funded by NUSI, which is the organization originally founded by Gary Taubes and Peter Attia to test the carbohydrate insulin model of obesity. This is the third of the three major studies run by the NUSI. The first two of which were one called Diet Fits by Christopher Gardner. He's now on Twitter if you want to follow him, and the other by Kevin Hall, which was a metabolic ward study, who's also on Twitter if you want to follow him. This is the third of those three major studies, the trinity of NUSI studies. This study purported to show that there is a metabolic advantage with low carbohydrate. In particular, there is a roughly 200 to 300 calorie per day advantage for low carbohydrate diets compared to high carbohydrate diets. And it's even worse in those with the highest third of insulin secretion, which saw an even greater metabolic advantage from the low carbohydrate diet. And that is one of the highlights of this study, something that makes it unique, which is that it stratified the participants by their baseline insulin secretion, thereby directly attempting to test one of the aspects of the carbohydrate insulin model. Before I continue talking about the carbohydrate insulin model, it's important to specify exactly what it is. And that is, it is a model of obesity that originally originates from a fellow named Richard McCarnes. And here is from Dr. McCarnes's bestseller, 1958 bestseller, Eat Fat and Grow Slim. As we can see here, in the case of bread, potatoes, cake. Cat, please go away. Thank you. The person eats, get out of here. The person eats carbohydrates that is in excess of the daily need. This dampens metabolism and weight is gained. On the other hand, whenever this person eats fish, butter, eggs, or meat, it stokes up the metabolism, quote unquote, removes water, mobilizes fat, weight is lost, extra calories are burnt. This is the hypothesis that this particular study is trying to test. It may have originated before Richard McCarnes. I tried to track down his sources in his book. I could not find them. Although I haven't read the entire the entire body of work of Richard McCarnes, so I don't quite know if he has it somewhere. Nonetheless, that is the idea. And here is another figure from the same book. As we can see here, Mr. Fat and Easily eats carbohydrate at the center of the figure. It turns to fat. Little is available for energy, so this idea of internal starvation, because when you eat carbohydrate, according to the carbohydrate insulin model, an updating of this particular figure's model, because they didn't talk about insulin and carbohydrate in the relationship in these particular theories, but this carbon insulin model is layered on top of this model that we're seeing in front of us. But whenever you eat too much carbohydrate, it causes insulin to surge. As a result, the energy substrate gets sequestered in the fat cells, in the muscle, in the liver, and then there's little available for energy as a result. Again, insulin isn't shown here, but the carbohydrate insulin model of obesity, which became popular after this particular book became popular. Hold on a second, I need to get my cat, it's driving me insane. Let's continue looking at this model. Again, little available for energy because the insulin has sequestered all of the energy substrate, so you soon feel hungry again and you eat more. So there's idea of internal starvation. You can see he's eating more. This only makes him fatter because he's sequestering it away and not having it available for energy. Then he still feels more hungry. He eats more. He's fatter still and still not satisfied. And then so it goes on and he becomes obese. So this model has been around for 60 years, perhaps longer. This is the furthest back again that I can track it. But it's been around for a long time and we're still trying to show that it is the case. In this particular study's case, it is using the most sophisticated technology to try to do so. Its claim was that in the low carbohydrate group in this particular study, they saw greater energy expenditure, and in particular in those who secrete high levels of insulin, which would match the carbohydrate insulin model of obesity. Because again, those people who secrete high levels of insulin, whenever they consume a high carbohydrate diet, will secrete a lot of insulin, sequester away a lot of that energy, become hungry again really quickly, not be able to use that energy, metabolic rate will plummet, they'll need to continue eating food, and then they'll become obese. However, if they use a low carbohydrate diet, since there's such high insulin secretors on the low carbohydrate diet, they will see disproportionately higher they'll see a disproportionately ramped up metabolism because they won't have insulin getting in the way anymore. So this is what this study purported to show, namely that the low carbohydrate diet increased the metabolic rate, and it particularly did so in those people who secreted high baseline levels of insulin. Great. Let's talk about why this study needs to be placed into context, and in fact, it's controversial, it's not definitive, and it has many features that call some of the findings into question. This doesn't mean that what the study found is wrong. It could be correct, but this study needs to be confirmed by additional research. And, well, let's just get into the details about why this is the case. Here's a really interesting tweet by Stephan Guyenet. Stephan Guyenet is an obesity researcher. He did his PhD at the University of Washington, and he also did his postdoc at the same university with Mike Schwartz, who is a luminary in the field. And what he's showing in this particular figure is in all of the studies that have been done exactly like this one study, or at least that have been done in a similar manner, looking at a similar set of questions at this study, they saw these results. Specifically, whenever they looked at the 28 studies done, 20 of the 28 studies found that there was actually a higher energy expenditure, a ramped up metabolism on low-fat diets rather than low-carb diets. The weighted average was about 26 calories per day increase in metabolic rate on a low-fat diet compared to a low-carb diet. This amount of increase is not clinically significant. It's not really going to result in any major change in weight in any particular person, because the determinants of energy expenditure that are highly relevant to obese persons are of a much greater magnitude as a whole than 26 calories per day. As a result, it's not a big deal. So basically what this is saying, this review of these studies is saying, is that there's no basic difference between a low carb and a low fat diet in terms of energy expenditure. This particular figure is either derived from a paper from Dr. Kevin Hall, and Dr. Juen from the National Institutes of Health, or it is copied from that same paper. I believe it's actually derived and repackaged by Stefan Guyenet. Now, as we can see, the study by Ludwig and Ebeling, this is the study that we were just talking about just a moment ago, saw a 200 calorie per day increase on a low carbohydrate diet versus a low fat diet. Placing that into context is very interesting, because only 8 of 28 studies have found a result that it favors a low carbohydrate diet over a low fat diet. And what's more is only 2 studies found a 150 or more calorie per day difference between the 2 diets. Ludwig and Ebeling found an unprecedented 209 calories per day, which is greater than any other study has found so far in a difference between those 2 diets. So Dr. Ludwig's study is an outlier in the body of literature. In fact, it's quite an outlier. This is the first major problem. It doesn't mean that this problem doesn't mean that the study isn't correct. It could be correct. It could be correct because this particular study could have done things in a way that is better than all the other studies. But since 28 studies have been done, and this is the 29th study, it's unlikely that all of those studies are incorrect and Dr. Ludwig's study is correct. What's more likely is that the estimations done about these other also very prestigious and prominent researchers, in some cases, on a strictly probabilistic basis, without looking at the papers themselves and analyzing the papers themselves, it makes the findings of Dr. Ludwig's It poses questions about the findings of Dr. Ludwig. That doesn't mean, again, that these findings of Dr. Ludwig are incorrect. It just means that this particular study is very unusual. And that prompts a question. Why? I think that's fair. Okay. So why? Before we get into the nitty-gritty details of why, although we're not going to go into the great depths of detail because it can get too technical. Let's do an overview of how this study was designed. As we can see, there was a run-in phase where the subjects who were overweight or obese had a run-in diet that was the same with all participants, where they lost weight. And it looks like it was about 10 weeks long. Okay. Then what happened is they had their energy expenditure tested using what's called doubly labeled water. Basically, the double labeled water technique is a highly complex thing for me to explain in just a couple minutes. It will take a little bit longer than that. The key takeaway from the double labeled water technique, the basic concept that it depends upon, is this. When you eat food, the food that you eat is turned into energy in your body by breaking the bonds between the atoms of the food that you eat. Specifically, in each energy molecule that you consume, whether it be glucose or fatty acids, the bonds between the carbon atoms provide your body with energy. These bonds are broken. The carbons are turned into carbon dioxide and then exhaled. So whenever you report food intake, then you have some idea of how much energy is taken in and used up. Also, whenever you track how much carbon was excreted in the carbon dioxide, then you can have an idea of how much energy was being used, assuming somebody's weight stable. The double label water technique depends upon these kinds of ideas. It's really complicated to go into in any more detail than that, but just remember the basic idea is that you excrete carbon whenever you breathe out the carbon from your food. That's an indication of how much energy you're using, the rate at which you're excreting that carbon in your breath. And then the amount of food that you're taking in is another way of determining energy, assuming weight stability, determining either through calories in or calories out, combined with looking at whether you're maintaining weight will allow you to determine what your energy intake and energy expenditure is. Okay, that said, what is the problem with this particular study? The problem is, as we see in a recent Biorxiv submission by Dr. Hall and Dr. Guo, there are these basic problems with the study in which might account for that outlier status that is reported by Stefan. And here's the basic problems. First, the original plan for the study was not followed in analyzing the data. So why is this important? Well, it's very important, especially recently over the past 5 or 10 years, for what's called the reproducibility crisis in science. A lot of times results are reported in scientific publications and are found later on not to be replicable by further studies. The reason for this is there's multiple different reasons, but one of these reasons is that when you take data from a particular study and you don't have a plan for analyzing that data, and then you just look at it after you get it and then try to find ways in which some of the relationships between some of the variables might be statistically significant, you can find a signal in any amount of noise. To take an example about how this is true in everyday life, if you look up at the clouds, eventually you can see faces, you can see figures, you can make up a whole story about what's going on up in the clouds because you're turning this random noise of clouds into figures that you're then able to say a signal exists for. So you're taking random noise, you're generating a signal up from it, because eventually when you cut up data in an infinite number of ways, you'll eventually find a way in which it appears, at least on first glance, to be telling a story, to be giving a signal, when it actually doesn't exist. It's actually you doing that actively with your own mind. Same thing works with scientific studies. If you get enough data, you can make the data look significant whenever it's actually a chance finding. So when you don't pre-specify your analyses, or you change your analysis that you pre-specified, the risk is being run that you're actually just looking for and finding statistically significant changes when you're actually just looking at noise. Basically, it ruins the integrity of a study when this is done. The problem in this particular study is one analysis was pre-specified and they did a different analysis than the pre-specified analysis. So they published this pre-specified analysis online on one of the, I think it's on a government website where you can pre-register these studies, and they did a different analysis. And here's the big kicker: they did this different analysis after they already had access to the study data, which makes things a little bit even more suspicious. It's very unfortunate, in fact. So as we can see in Dr. Hall and Dr. Guo's Biorxiv pre-publication, they write, the analysis plan was modified in 2017 after all subjects had completed the trial and after primary data for the first 2 of the 3 cohorts were returned to the unblinded principal investigators in Boston from the blinded doubly labeled water laboratory in Houston. Nonetheless, according to the principal investigator, the Boston statistician who performed the data analyses was unblinded to the data assignments only after the primary data were returned from the Houston lab and after the revised analysis plan was registered. So in other words, they had access to the data, but they didn't look at it. They then changed their analysis plan, conducted that analysis, and found these results. So they contend that there was no foul play in this particular case. But Dr. Hall and Dr. Guo go on. The change in analysis plan was not acknowledged in the original manuscript submission of the BMJ and was not reported in a previous publication of the trial design. So this is very unfortunate because it casts a shadow, again, over this particular study. It doesn't mean that the study didn't find something that's real. It could have found something that's real, and if it did find something that's real and this is verified, that would be a great thing because then we have another tool to help obese people with. But however, because of this discrepancy, this casts a shadow over the study. It's unfortunate, and in fact, I think that that this was a mistake. This change should have never happened, and so whenever they did the pre-registration of the analyses, they should have looked at that pre-registration. Everybody made sure that it was correct. Everybody signed off on it, looked over it several different times before they submitted it to the pre-registration website, and then this problem would have been avoided. But because they didn't do that, now there's this shadow of doubt cast over the study, and it's very unfortunate. But it is what it is. The other issue is that the justifications for this change are not very good, according to Dr. Hall and Dr. Guo. And they think that the original plan was better. First of all, because it was the only plan that was registered, but for some other reasons that are also important. Specifically, whenever they did the energy expenditure estimations, which is what I talked about earlier with the carbon and that energy intake stuff, they did this while the subjects were refeeding. This particular method of evaluating energy expenditure has not been validated while people are refeeding, so this introduces a lot of variability or potential for variability or potential for bias into the equation here. And so this is another problem with the study, and potentially why it's an outlier among all the other studies that have been done by this, like this. Whenever you reanalyze the data according to the original pre-registered analysis plan, you don't see a significant diet differences. So you don't see a statistically significant difference between the high and low carb diet, which again is another reason why you sort of just have to. It's another reason why what happened in this particular study is unfortunate, because they have these findings, they put millions of dollars into the study, but the pre-registered plan was not followed. Whenever you do follow it, you don't get differences. Whenever you don't follow it, you do get differences, and it was chosen not to follow whenever the investigators had the data. And this is extremely unfortunate and it's very regrettable, but this is what happened in this particular study. There's some other technical details that I will not go over about this particular issue. There's also the other issue is that the energy expenditure changes in the subjects might have been confounded by basically inaccuracies in the double-labeled water method caused by the aforementioned problems. And there's evidence for this in that the intake reported by the subjects, and this intake was from foods that were provided to the subjects by the investigators themselves. So this is tightly controlled. This tightly controlled intake that was reported by the investigators of what the subjects actually ate is at odds with the energy expenditure by the methods used by the investigators, namely the double water method. Because there's this difference, it calls into question how accurate the double-labeled water method is in evaluating the baseline energy expenditure. So you need a baseline energy expenditure, and then you need a energy expenditure at the end of the study showing that there's this change in energy expenditure that favors the low carbohydrate diet. Well, because in this case the subjects which most contributed to this large energy expenditure change that caused the low carbohydrate diet to be favored were the ones with the largest unaccounted energy whenever you compare the reported energy to the energy intake obtained by the method that's being used to establish that the low carbohydrate diet gives a metabolic advantage. So again, there's this other discrepancy that is very problematic, and it might follow from the fact that the doubly labeled water method is not properly validated in subjects who are undergoing refeeding. Before we continue, it's actually worth looking at another paper that was published, or is actually published this month by Dr. Hall, Guo, and colleagues, including some heavy hitters like Dr. Leibel and Dr. Ravusin at, I think Leibel's at Columbia, and I think Ravusin's at Pennington. That's right. And they're highly regarded giants in the field. And they wrote this paper where they suggest that on a ketogenic diet there are discrepancies between the assumptions made about the doubly labeled water method as has been used to this point, and what the actual energy expenditure is of people who are on a ketogenic diet. So specifically, the idea is a ketogenic diet has not been properly validated for the doubly labeled water method. This is another reason why this particular study might have overestimated energy expenditure on a ketogenic diet. And let's see if we can find what they're talking about here. So because a ketogenic diet affects a particular variable that goes into calculating the doubly labeled water in a way that's not expected, Dr. Ludwig's study might have overestimated the effect of the ketogenic diet. So again, these technical details are having a lot of play here because the ketogenic diet is new. The doubly labeled water method is a little bit older, but because the ketogenic diet has not been used so much with the doubly labeled water method and has not been validated, this particular problem might undermine the study. Can you get out of here, Kat? Can you go somewhere else and stop it? Thank you. So the final issue is that this change in total energy expenditure as measured by double labeled water was not corroborated by other methods of looking at energy expenditure. So for example, resting energy expenditure, total physical activity, sedentary time, skeletal muscle work efficiency, and all these other things that are not different between low and high carbohydrate diets, yet somehow the total energy expenditure is different, which suggests that the method being used to look at total energy expenditure is not appropriate for looking at this particular question. Or because it suggests that this method is inaccurate. On the other hand, it could also mean that there could be some sort of change in thermic effect of food, sleeping energy expenditure, some other unmeasured factor contributing to total energy intake that was not looked at by these other measures. So that can't be ruled out. In that particular case, maybe these other methods are simply basically not getting at the true source of the increase in energy expenditure that the total energy expenditure variable does get at. And for this reason, this particular criticism might not be meaningful, but again, it's another problem that adds to a total basket of problems with this particular study. And here's quite interesting criticism, which is that the total carbon dioxide production is not different between the diets. Well, if the total carbohydrate production is not different between the diets, that would suggest that as we said before, since carbohydrate and fat are turned into carbon dioxide through the breakdown of the bonds, these bond breakdowns being used by the body to generate energy, then the daily average carbon dioxide production should be different. However, they weren't. So that's another problem. It suggests that the double labeled water calculations somehow got things wrong. So the basic idea is because of some of these potential problems with the study, and because this study is an outlier in the body of literature as exists to this point, you can't say that keto has a metabolic advantage over a low-fat diet or something along those lines, because this study is a very controversial study, and it doesn't comport with the evidence that we have so far. And what's really interesting is the next point, or at least I think it's interesting, the next point I'm going to make, which is that we see maybe even a metabolic advantage for a low-fat diet whenever this analysis was conducted by Dr. Hall, this meta-analysis here, Dr. Hall and Dr. Wu. It's interesting to note that whenever you look at children who are on keto for epilepsy, you see measures of subclinical hypothyroid. For example, in this particular case, you get about 1/6 of the kids who are using keto for epilepsy. I want to say 6 months or a year. You saw 1/6 of these kids get hypothyroid, and the corresponding changes in blood lipids that happen when one has hypothyroid. In another study, I think this one's going to be by, this is not the same study. In another study, they also found a similar thing. They found that you had lower levels of T3 hormone, which again is the active form of thyroid hormone. The T4 is the inactive or less active. If I recall correctly, I think it's the less active form. And what we see here is we see the same thing, a decrease in T3. And you see the same thing in a study co-authored by Stephen Finney in 1983. T3 fell by half in 4 weeks on an isocaloric, same protein ketogenic diet in 9 men. You see the same thing in Dr. Hall's metabolic ward study, I believe published in 2016, where you see a highly significant change in free triiodothyronine, which is T3. And in this particular case, we saw a drop in about, I mean, it's not that large of a drop. It's what, 30? It's like 17% of a drop or something along those lines. It's a little more than that. It's a little less than that of a drop. So maybe 15% drop in free T3, and actually a 25% or 22% drop in the total T3. And highly significant to something like 1 in 10,000. So T3 drops on a ketogenic diet compared to a higher carb diet. And we know, or it is believed in the literature as the consensus currently exists, that carbohydrate is the largest determinant of thyroid function. I haven't shown those papers, but those papers also exist. That said, that kind of explains why a low-fat diet might be favored over a low-carbohydrate diet when looking at energy expenditure. That is to say, the low-fat diet may speed up metabolism. There's another wrinkle here that is actually quite fascinating, which suggests that essentially so this has been shown over and over again in many studies. This is just one particular study. They say higher altered injury. I don't know if that's the case, but we know that high thyroid stimulating hormone and actually low thyroid hormone is associated with longevity, and the reason is that metabolic rate is to some degree reduced whenever you have a lower thyroid hormone. So people with genetically lower thyroid hormones, I think in Mendelian randomization studies, it shows they have longer longevity. So what this would suggest is that you actually don't want a higher energy expenditure, especially if it's driven by thyroid hormones. So perhaps the metabolic advantage of low-fat diets over low-carbohydrate diets, as reported by this particular meta-analysis, actually is not desirable. And so maybe you want to lower metabolic rate. And actually Joel Fuhrman says stuff like this. I'm not a super big fan of Joel Fuhrman, but in some cases I think he says some interesting and good things. And he says you don't want a fast metabolism, you want a slow metabolism, and I think that's right. And in this particular case, this is why the thyroid hormone issue, and so it might be that low carbohydrate diets are good because they slow down metabolism. All right, so there's one more wrinkle, if I can remember, before moving on, which is that I don't know if I can remember it off the top of my head. Sorry, it's a bit late, and I'm actually a little bit compromised at the moment. It's actually right about the time for me to go hit the sack, so probably my brain is shutting down. There's one more point I really thought was interesting. So longevity, low thyroid, you want... Can't remember. Let's continue. Okay, so those are basically the problems with this particular study. again, it would be great if this study ends up being true, but it appears that if this study ends up being considered a path-breaking study, it will only be because some future study looks at these results, decides to try to replicate them, and successfully does so. At the present moment, we can't really say that low carbohydrate diets on the basis of a single study cause a metabolic advantage. We really need further studies to show this, and I believe Dr. Ludwig himself suggested that this was the case. Other studies on, I think that that's actually a good way to wrap things up. Thanks for watching.